Okay, hello everyone. This is gonna be very first video that we're gonna make for this series, of course. As you might know, the situation for COVID-19 is more serious than ever. It's become pandemic. Me also put into self quarantine for the 14 days before, and to be honest, we shift everything to be online regardless of the announcement of the university. Simply because um, if the worst case scenario happens and we have to shut down the university, but I mean, this is this problem of this country as well, that we doesn't have the regulation of how to help the student. Basically, even though they're gonna terminate this semester or not, if I put this material to be online materials, it's gonna help you guys later on in any kind of sense. So hopefully, the video is gonna be bright and clear. I want to make sure first that this early video, the audios, is good enough. You might not see my face or the gesture of me clearly yet. Okay, so this video I want to jump on the real programming languages that we're gonna use in this semester. As I mentioned before, that even though personally I don't care much about the programming languages skill that you're gonna learn, I care more about the programmable thinking that you learn from this class. However, to pass the standardized license as an engineer in Thailand, in near future they're gonna including debugging code in C languages as the exam and the basic criteria that you have to learn. So this course gonna based on C anyway, and I want to show you why C languages is important to the industry. So what is C languages? Why is named C? It's pretty weird because when I'm still a student, I'm also wonder like, and there are many good names in the world. Why it have to be just C? So if we look back at history, and maybe that is nature of us, the inventor or the engineer, the great engineer in the past, they also some kind of nerdy person as well, like us. So the very first languages is also like languages A, and developed to be languages B, and then in the end in 1972 it's developed to be C languages. So the C languages is developed and designed since 1972. Actually, we didn't know clearly when is the starting point that Dennis Ritchie really started to think and develop C languages. He tried to develop a lot of programming languages before when he worked at Bell Lab. But anyway, like in 1972, he started to announce that okay, we have C languages developed in Bell Lab. The good thing is that it's originally designed for Unix operation system. You might not heard about Unix much anymore, but it's a kind of like core operation system that many operation system right now develop further on. So basically, Linux, and Linux is also the kind of Unix variant. Also, Mac OS as well is a kind of variant that developed on top of Unix operation system. And then you can see like many variation can be later on like Android or iOS, which is both adopt main core concept of Unix operation system. So C languages is very first languages that being standardized. Why it's important? Like why I have to mention here that it's being standardized. Imagine back to like in 80s. So in that era, what happens? The world is just past industrialization for not quite long time. Computer just born. Many competitors in the market try to compete how to put computers into real device that consumer can buy. For example, like in that moment in time, you didn't have air condition that have inverter system yet. You doesn't have smartphone. You doesn't even in your car, it doesn't have navigation system yet. So the idea is that many people try to develop their own microcontroller or microprocessor to put it in the device by themselves. The problem is whenever you design the circuit by yourself, then you need to design programming languages that used for control the device as well. And every industry, like they are competitor to each other. At first, they try to develop their own languages one by one, try to compete each other about how fast they're gonna produce these languages and launch to the market. Then computer scientists came into the forefront and said, like, okay, if you keep fighting each other, then you're gonna slow down the whole process of developing system because you don't really know how to standardize the machine. For example, if I buy like this, like a USB transceiver, I want to make a mouse. I want to make a Bluetooth mouse. Nowadays, you can buy this transceiver from China, for example, as a good source, cheap price. You buy it, and then you put this one, and you can synchronize the information from this device to the circuit board that you design for your own prototype. The problem is, if you don't standardize the control languages, I need one language for writing the control for this USB device. I need another programming languages for writing and control my own prototype, which is kind of hectic. And we didn't want to have like 30, 40, 50 languages like implement one by one for integrate the whole system together. So C languages become popular in the sense that both ISO and ANSI also standardize C languages as a main standard in industry. So every company will know for sure that if they buy the part from for example, like if I buy one part of the circuitry from one company and gonna use in my company, I can use C languages to control it. And that is a big thing that fastened the developing system in the world up until now. So to tribute to him, Rishi actually passed away mostly quite the same time with Steve Jobs. Not many people know that because I know like Jobs is a big thing. I also adore him. But in the same time, as a computer scientist, Rishi is also one of the main influencers in the real programming languages that we use in the modern days. So yeah, please keep in mind that he's the guys that help you have smartphone and everything else later on in your life. So C languages, why is popular? First of all, I already say like it's being standardized, which is like the main popular things. And the other thing is they facilitate structural programming. We're gonna learn more about structural programming later, but then to put it short, it's like you writing the code one time and then you can reuse it. Thinking back about your Scratch project, many of you have to write the same function again and again and again and again. Even though it's just like dragging the jigsaw and put together in Scratch, it's still really annoying at some times. And to be honest, you want it to be like you want to write it only one time and reuse it again in future. Don't want to rewrite everything from the scratch. So the idea of C languages is have structure in the languages that help you to do that help you to write the code for once and declare it to be a package or function. Then whenever you want to use that package, you just call it. That is structural programming, and we're going to learn about it later on. So it provides low-level access to memory. And that's why it's become big in the past. Because imagine that not that too long ago when I was young, when in 19 around like 1990s, 1998, around that, when we still have like Game Boy controller, or when the PC is still like this huge in size, and we need to have one disk just to open the computer. You cannot press the open button and it's not turned on. You need one disk to operate it, and that disk itself is like this big. It's bigger than your CDs nowadays. It's called floppy Bs, and those disks itself have the memory of just around like 4 megabytes. 4 megabytes in the past, extremely big data. You can write maybe a whole thesis in that 4 megabytes. Nowadays, what you can do with 4 megabytes? Just take one photo, right, with your iPhone. Normally the images now it's gonna take 4 megabytes, but in the past it's a very, very huge amount of memories, and we need to put and cram down everything in that 4 megabyte space. So the languages that can control how you access the memory, how to be efficient of using memory, is going to be popular in that days. Also, C languages is very, very first languages that allow you and also encourage people to do the cross-platform programming. What does this mean? It means that in the past, IBM also tried to develop their own operating system. We have Unix that scientists use for free. We have Apple. We have Microsoft. We have many variants of operation system like fighting in the computer market. But C jump in the middle and say like, okay, whoever you are, which operation system that you use, you can write the code in C. You can write C in Mac OS, transfer the code to the Windows OS, is still usable. And that is a big thing in the past, is help people to cooperate and work together. And also, up until now, C languages still being standardized. And until now, it's being used in industry because it being standardized. Industry wants something that's certain, steady. They know for sure what they get. They know for sure how to modulate it. They have the document that describe every single bit of it. That's what industry really want. They want security, and C can provide that. So the legacy of C languages is that they have many C variants came out later on. It's including C++, C#, C shell, which is used in Unix, and also have Objective-C, which is the first languages that used for develop iOS application. When I'm student, we used to use Objective-C in that past. Up until now, I don't really know anymore that we still use C languages or not, Okay, and next thing that we're gonna have is that we're gonna have the languages that adopt the control structure from C, which is the main legacy of C, because it allows people to control every single bit of memory, can pass data from one function to another, can reuse their code. So you can see that most of modern day languages adopt the structure from C languages. And that's why it is one of the biggest influential in the computer science in the past, maybe I would call in the past century as well. So you can see that most of the things still until now developed by C and C++. So if you look at the base core code of Microsoft application, most of them include operation systems still developed in C and C++. Most of computer graphic program still developed in C and C++, not Python, simply because C and C++ allow you to access to the memory, and the 3D program require a lot of computational power. I mean a lot. So if you don't want to burn down your cash to buy high performance computers, then you need to use most effective like programming languages like C, or even like in some program they go deeper than that. They use something like further than C to control the memory, but we can talk about it later. So the Bloomberg company for stock market trading, Adobe, you know it for sure for Photoshop, and as I say, it require a lot of computational power, and to make it run smooth enough in the compact size, they still have to use the programming languages that you can control the memory. And for sure, Apple company have a lot of legacy of C languages, including develop their own variant of C, which is called Objective-C, and right now change to the further version is called Swift languages. So if you look at the industry, what industry still use C languages and still use C++ languages? So you can see that even though right now Python is kind of very famous languages in the industry, but they have some domain that Python cannot do and C can do. You can see like C and C++ mostly gonna have the broad variant of things that they can do, including mobile application and desktop application here, and controller. Here is images of microcontroller, which just mean that how much you can control the electronic circuit, something that you can use in the front line in the industry, like the control board in the petrochemical industry. And here some C variant like C# can develop the website as well. So yeah, main thing that standard C, not C++ and C# still used mostly in the industry is to control electronic circuit. The Arduino board is one of the most famous one that you're gonna find in the industry. It's used both in educational way and also used for control the real commercial devices, which is integrated. This board that you see right here is the thing that integrated in many of the devices that you use nowadays. It can be shrink down into this small circuit size, but can recording the code and calculate it like the small smartphone to make it more simple. And then you put it in refrigerator, air condition, or in television to make it to be smart TV, smart air condition, smart refrigerator, and smart IoT device. Okay. And why C is become more important in industry, especially when you use Windows. I don't know, like most of you use Windows system or not, but now this example is based on the Windows operation system. So in most of languages, when you're writing the code, like in the Scratch, when you put the jigsaw together, that's also the way to writing the code. This code will be saved in a source file, what we call source code or source file, which is provide how the code being written. And mostly it's gonna be in a shape and the form that human like us can interpret. So like in Scratch, you still be able to tracking the flow of the program a bit by look at the jigsaw. In C languages as well, you can look at the flow of the code and be able to interpret it a bit by bit. But to use languages to control the machine itself, as I mentioned before, is use different languages than us. Like in ASCII code, if you remember, the machine have some table to remember characters in specific number. Like 128 is gonna be number C, for example, be character C or something, for example. Then the idea is that that source code have to be compiled. This is the word that we use. It needs to be translated or compiled into the compact site, and that compiled file gonna be linked up together to be the machine code that you can recall in your program, like .exe file, which is this one is mean executable program that you can double click on it and it start to run immediately without any process of compiling. So the idea of compiling is like you use Google Translate, but it's something like not easy like Google Translate. So the idea is like compiler gonna be moderators that transfer languages that we can read into low-level programming languages that machine can read. So sometimes C languages being used and being called as a middle level languages because it's bridging the gap between the high-level programming languages and low-level programming languages. To give an example, I'm very familiar with Python. I'm a data analyst. So for data analysis, most of the times, the Python code and Python library cannot do what you want it to do because it cannot directly control the machine. So we developed something called wrapper. So we use Python languages to wrap around C languages code because Python cannot access memory directly. So we use Python code to contact to C code, and then from C we can contact the memory directly at the machine. That's helped a lot because I can be more optimized on how to control and manage the memory on my system. So to develop something in C, I have something for help you is the IDE or developing program that's gonna help you for coding and learning C languages in this course. So we're gonna use something called Code Block. What is Code Block? Code Block is like open source cross-platform program. I use this one because I tested and I realized that okay, it's used and work well and consistently in both Mac OS and also in Windows OS. So regardless of the OS that you have, you can download the software here in the Code Block website, and you have to select the binary releasing. Then inside there you're gonna have like Linux version, Windows version. Try to download the one that have WinGW set up for you for Windows user. So that's gonna help you in the later section of the class as well. So the guideline for installation is that after you download it, you double click the program, and then it's gonna have the standard wizard that you can just click next and agree. Make sure that here at the bottom, right here, if possible, please put all plugin including MinGW compiler suite inside your installation. Then select the place that you want to install and wait for it. Then they will ask you that you want to run the code block right now or not with the interface that helps to recheck what being installed and not being installed in your program yet. And then in the end you click OK, and then you can try to start create your new project, and then click add the console application and then click next. Then they will ask you're gonna use C languages or C++. Okay, select file name and so on. So instead of just this we put it step by step in the slide simply because it's gonna help you to navigate around if you don't look at the video. The idea is that we're gonna show you right now and how to run it and how to control the interface, basic interface of the code block, including very first program that you can do with it. So Right now I'm going to stop this PowerPoint presentation, and then we're going to switch to this interface. This is code block. Okay, but first of all I'm going to run through the installation system. So the main idea is that we click at, yeah, it's gonna be a little bit strange because I have to look at another monitors right now to collecting, because like we streaming data back and forth, and yeah, you're gonna see me like I'm looking out forward to somewhere, but actually I look at the code with you. So the idea is that if we have the installation file that you downloaded in your computers, and then here at the installation file, if you double click it up, what happens is, for sure they're gonna ask you about a couple of things. Okay, this is installation wizard. The main thing that, again, I want to remind that you need to make sure that you have to put MinGW inside. It's going to help you later on in the later class that you need to develop some more fascinating program. And you can see like the size of MinGW is not that big. Okay, and then you select where you want to put the code block in. Either in drive C, drive D, whatsoever, it depends on you. And then you click install. And then after it install, then when you open it for the first time, it's not gonna look like this. It might look like, I think it's gonna look like, I know. Yeah, anyway, you're gonna see, you saw it in slide that what it looked like. I will clear this one first to make sure that we will start everything from the scratch together. So the ideas of code block is that they have the area on the left hand side to help you to store your project. So I recommend you that, for example, like for this semester, you create new project here, file, new, and then project right here. Then most of the work that we're gonna do, we're gonna work on the console application. So you click it here, then you select C languages, and then right here you need to indicate two things. So the first thing is that where you want to put your project on. I recommend you to create one single folder to keep all project that you work in this semester together. Make sure that you not lost any file. For example, if I would like to, I will make new folder right here and say like CPE100 class workspace, for example. Okay, and then you need to state the name of the current project. So the way it works is every program that you run or create later on gonna be integrated in that single project. For example, I'm gonna do something like first program. Okay, then you need to select, this gonna be default, it's gonna be GNU GCC compiler, so you can start clicking finish, and then it will create the space here for first program for you. If you click inside, it's gonna have source code in C languages created for you as well, and it is the main function that you can writing the code inside. Then next step that you have to do is that you need to click at this one, build and run. Okay, if you click build and run, it's gonna have two results that can show. Either it simply show this console, which is gonna tell you like how long the program used for running the whole program, which is like 0.1 seconds. And then it's gonna have the text showing here, hello world, which is simply say like your program is work correctly. The problem is many of you might have error in the first time that you run code block. It's gonna have like the red color message here stating something like error, we cannot find debugger, or something related to debugger. So what you have to do, you have to go to setting, go to debuggers, then you click at default down here, and add executable path. You have to browse and go to the place where you install the code block. For example, for me, I install code block inside program file. Then I double click at the code block. Then there we have min.gw folder, and then I go to min.gw or gbd is gonna be okay. Both of this, I go to gdb and then bin, and then double click at gdb32. Okay, this when you finish whole thing, which is you indicate the place where debugger is in your system, then you click OK. Then what we have to do is we terminate this one, and then we run it again to make sure that program work correctly. Whenever it's work correctly, you're gonna see the output showing up. Okay, that's it. That is simple thing that you're gonna do. Mainly here is an area that you're gonna see data file, source code, and most of the thing. Here is an area that you use for coding the program. Okay, and mostly you're gonna use these two functions here for build and running your program. You cannot run it if you don't build it yet. As I said, build is a word that they use for compile, to change your code to be the machine code first, and then from that machine code you can run it. Okay, debugging gonna be the thing that we use in the future, in near future, to learn how the program works, to learn how to check where is the mistake that you made in the program. It's like in the scratch, if you mess up something a little bit, then program cannot run. Okay, and simply in C languages, they have a couple of things like the patterns that you have to learn. First of all, every single code, every single line of code have to end with semicolon here. Okay, what happens if I didn't include semicolon right here and I try to build and run? You see, the code block is smart enough and gonna help you if you start reading a message and not panic. Okay, when you run it and it's not work, don't panic like, it's not work. No. Like trying to look at the code first. They say like, okay, the build message have error, and they say like in line number 7 they expect to have semicolon here before return. So they say like before return, so you look at return. If you put semicolon here, it's gonna be a little bit strange why it have to be there. So simply speaking, you have to go back to this line, one line previous, and then put semicolon on top of it. Okay, that's gonna be easy and simple, and then you save it again and you run, build and run, sorry. So the printf here is like what you use in Scratch to let the cat or your avatar to speak something. But now instead of speak directly to like like in the front of the screen, it will print it out in the console in that black single screen that you see. Okay, so the idea is that whenever you put anything in printf, it's gonna write it down in the console. So example like hello world here, if I do something like hello world and then I put my name in here, like hello John Wood, and then I build and run. Okay, you can see here it's changed to be printing my names. So it's mean like we can print many code. I want to show that code block also have feature like you type couple of words, then they will suggesting the whole code for you. Like for example, I want to print when I just type PRI, and then it will suggest printf on top. So you press tab button, then it will insert the whole patterns of the code for you. It's gonna help you in the coding, make it more convenient. Okay, and I might put something like how are you? Okay, again, don't forget your semicolon and you save it. Okay, then I build and run. Sorry, like my computer is gonna be slowed down a little bit. I forgot to plug in the power supply, so yep, it's gonna be fine. Okay, so you see now is have both hello Kajon Wood and how are you today. So you might wonder why I have to put that \n here in the code. So we might try simply to cut it out. Okay, and then we run the code again. To see what really happens if I don't put \n inside. Yeah, you see, machine simply doesn't know when to go to the next line. Okay, when to print to the next line. If you doesn't have anything to indicate the machine that okay, after you print this message, you need to press enter and then go to the next line. If you doesn't indicate them, what they did, they just simply put one sentence, binding it with another sentence immediately. Doesn't do anything more than that. So as I say, even though C languages is kind of interpretable with your eyes, you still need to learn and being familiar with languages enough to understand that okay, to go to the next line in C languages, we have to put \n here. If you want to go to use a tab, for example, you need to use \t, and this kind of thing gonna be a thing that you're gonna learn in next video, how to do the basic control of C programming languages. Okay, for now, I hope you understand it, can follow through it, and enjoy it quite a bit. You can work and play around with these interfaces. Next video will come soon about how to develop your very first program in C languages. Thank you for this time. Thank you for your attention as well. Goodbye. You can leave the feedback to us about any kind of thing that we can improve. Okay, thank you so much and see you around.